time. And last time we were talking about futures. And I said futures is something which is like forward contracts, only that instead of having a contract with another person, you are entering a contract with an exchange. And then I took you to Chicago, to the Chicago Mercantile Exchange, and I showed you these examples of future contracts which are being traded through this exchange, the Chicago Mercantile Exchange. So for example, we saw these are futures on, what was it? Oil futures, crude oil futures. And we looked at each row in this table that would correspond to futures of the same delivery date. So if I'm looking at this row over here, January 2019, then we're talking about futures, which are contracts between you and the exchange to either deliver or buy a certain number of barrels of oil at a certain date in January 2019 for a certain price. Now you can see from time to time these numbers are going to flash yellow and they're going to change a bit. It's a bit early for trading in Chicago, but apparently they get up very early. So people are entering these contracts either as buyers or sellers, and as they do that, prices change because there may be someone saying, ooh, I really, really want to buy this stuff in January 2019, and then there's no one is offering the exchange to deliver that, and then he waits a bit more, and so prices go up a bit, and then eventually as prices go up a bit enough, then someone is willing to take the opposite side of this contract. So if someone enters a long position in the contract with the exchange then has to find someone who's willing to take the short position in the same kind of contract. Now, we saw last time how to find prices of forward contracts. So if I sign an agreement with you on delivery of some asset in the future, we have a theorem that says what should be the price that is going to be agreed between us. The question is there a theorem that tells you which numbers should you read here? What are the numbers, what are the forward prices that people are agreeing on now? And the answer is not quite, but we have a very good approximation for that. So at the end of what I'm going to say now, we're going to learn that if you pretend that these future contracts are forward contracts, and if you make some assumptions about interest rates not being too crazy, then forward prices are very good approximations for future prices. But to see why you cannot use forward prices for future contracts, let me try to explain what a main difference between forward contracts and future contracts. So with a forward contract, I enter a contract with you, say to buy barrels of oil from you at some point in the future, and we agree on a price now. So now we wait until that delivery time. At that point, I pay you the agreed price, you give me the agreed amount of oil. That's forward contracts. These are simple things, we understand that. But now let's have a look at how future contracts work. So now there is not me and there is not you, there is an exchange. So I enter an agreement with the exchange, and suppose that I take a short position. You can see for how long I didn't update these slides. In May 2014 Brent crude futures, which is supposed to be in the future. So let's pretend that it says 2024. And suppose that we agreed on a price of 24.10. So I went to the exchange and I said, I want to sell oil in a certain date in the future, and the exchange says, fine, for that date, the agreed price is 24.10. I say, fine. And suppose that the underlying asset for this futures contract is 1,000 barrels of oil. So I say, fine, I'm going to provide 1,000 barrels of oil at this date in the future for that price we just agreed to. Okay? But now people are entering short positions and long positions. As they do that, there is more demand than supply, or the other way around, and prices fluctuate. And we get to the end of the day. So let's see. I had a short position, and the price was 24.10. And this is per barrel. And I committed to sell 1,000 barrels. Okay, so this is the contract I entered into with the exchange. And now at the end of the day, I observe the price that people are agreeing on, the closing price. Suppose that the closing price now is not this, but it's 24.20. Am I happy or am I sad? I'm sad because if I enter the contract at the end of the day, I would be selling my oil at 24.20 instead of 24.10, right? So I'm not so happy about that. But then here's this weird thing that happens that makes these future prices different from forward prices. The exchange is going to come and say, okay, this was the closing price for future delivery of barrels of oil. This is now the new official price of barrels of oil delivered at this point in the future. So the exchange comes to me and says, I'm going to change this to 24.20, which is great. I just earn 10 cents per barrel. I just earn $10. Sorry, $100. Right. So I just earn $100 by the exchange modifying my futures price. And how is this going to be balanced? I'm not expecting any gifts from the exchange. So I have to pay $100 to the exchange. Now, what is the exchange going to do with my $100? There's a long position shadowing this one. There's a long position which initially it entered, say, at the same price. For the same number of barrels. And that person agreed to buy 24.10. The exchange is going to come to this person and say, well, actually, the new price is 24.20. That person is going to complain. It's going to say, wait a minute, now I'm going to have to spend $100 more. And then the exchange says, don't worry, here's $100. Okay? And now, suppose that the next day, there's a lot of trading, prices go up, prices go down. The new closing price for barrels of oil is 24. And I'm really, really happy because now I can I have the right to deliver this oil at 24.20 while everyone else is getting 24. But then the exchange says, sorry, I'm going to change your price to 24, from 24.20 to 24, in which case I'm going to complain because I'm losing $200. So the exchange says, don't worry, here's your $200. And this person who was going to pay 24.20 for the barrels of oil now is going to pay 24. And then the exchange comes to this person and says, well, you just made a nice little profit, and so you're going to give me this profit, which then gets passed to the other person. Now, this looks like a complicated way of doing business, but I'm not justifying this or saying that this is mathematically interesting. This is how real life looks like. This is what happens in real life. And this process of adjusting prices every day and then passing intermediate profits and losses between different investors, this is called marking to market. Marking to market. So, futures, unlike forward contracts, are marked to market. So, when you look at your futures contract, the price, the futures price, is changed every day. Every day the exchange goes to your contract and says, the new price you're going to either deliver or buy this stuff is this new price. And it has all this complicated set of transactions to compensate for that. But this is telling us that we're not going to get a profit. Imagine that we were trying to do the same kind of proofs, employ the same kind of proofs we use to find forward prices in this new situation. Now we can't just borrow money, buy the asset, and wait until delivery and then deliver the asset for the agreed price. Now the price keeps changing all the time. So our proofs would fail there, and the failure of our proofs would be greater if... So what happens with these profits and losses we keep making every day? So these profits and losses go out of or come into an account, a bank account, a margin account, which pays interest. And what we're not taking into account here is what happens to these intermediate losses and gains, which are earning interest or paying interest. Now, if you make an assumption about the world, which is, let me just jump to it, if interest rates are constant and known in advance, so you know what's going to happen to all these intermediate profits and losses, then you can do a long accounting exercise and you can find out that the futures price is the same as the forward price. Okay? Okay, everything I've said today is no great mathematical significance. So you're welcome not to remember very much of it. But I just described to you two things. The first thing is how future contracts work. So if you find yourself in the real world having anything to do with futures contract, remember this lesson. The second thing I told you is in some nice circumstances when interest rates are constant or nearly constant, that our methods for proving the prices, that the prices of forward contracts should be what they are, what we said they are. These methods would work too, and then the futures prices are going to be exactly the same as the forward prices. So, again, if you find yourself asking yourself, is this future price I'm observing, does it make sense or not? Compute the forward price, and if it's very different from it, then probably that futures price is incorrect. Okay? So this is all I wanted to say about futures and forward contracts. Do you have any questions about this? Think about the question while I move to the new set of slides. Any questions about forward contracts, forward prices, futures, marking to market? Okay, so let's start with something completely new. We began this course by saying most of the time we're going to spend on trying to find the correct prices of some complicated things. These are the complicated things, options. So today we're going to see what options are, and then we're going to spend the next few weeks trying to figure out what is the correct price of these strange things. And in the process we're going to have to do some complicated mathematics. But let's start with the easy stuff, which is defining what are these options that we're so interested in. So options are contracts. And as any contract, it gives you certain rights. And since these rights are valuable, entering these contracts is going to involve paying some money. You're going to buy these contracts. But now let's see what are these contracts. So these contracts give you some rights regarding the buying and selling of some assets. So there's going to be a contract that refers to an asset. And we're going to call that asset the underlying asset of these options. So there are four kinds of options we're going to look at now. They come either as call options or put options. So let's start with an European style call option. So this is a contract that gives the owner the right to buy its underlying asset at a certain price, a pre-agreed price, on a certain date. Okay? So if I say, here's a European call option whose underlying asset is this monitor expiring in a year with a strike price, with a pre-agreed price of £1,000, then what did I just do? The owner of this call option has the right to buy this computer monitor for £1,000 in a year. That's what the European call option does for you. It gives you the right to buy something at a certain specified price at a certain point in the future. Okay, the second kind of options is European put options. So these are identical to European call options, only that it gives the owner the right to sell the underlying asset at a certain price on a certain date. Now let's give names to the various parameters you find in these contracts. There is the date in which you can exercise your right to buy or sell something. So we're going to call this the expiration date of the option. And there is the price which you have the right to buy or sell the underlying asset. And we're going to call this price the strike price. So where do you find these expiration dates and strike prices? So we're talking about a contract. So here's a European call. So European call is going to have lots of small print, which is going to say owner has right to buy some underlying asset, which I'm not specifying, underlying asset, a time expiration date, for strike price. So this makes this into a call option. The underlying asset is the underlying asset you underlying this option. You have an expiration date and a strike price. So these are the parameters of such an option that you find a small print. Now, if you have one of these, this may be valuable. So you go to a shop and you say, I want one of these. And then the shopkeeper looks at the thing you want, the European call you want, and is going to tell you, you have to pay this price. So this is the option price, which is not specified in the contract. This is the thing that we're trying to find. So we're going to try to figure out what is the correct price of this piece of paper. All right? Do you understand what these European options are? You keep forgetting. This means yes and this means no, right? Let's try again. Do you understand what these options are? Okay, I told you we're going to see 4 kinds of options today. So I've shown you the European style options, and now I'm going to show you the American style options, and they come also in the form of call options or put options. An American call option gives the owner the right to buy its underlying asset at a certain price, and here's the difference with European options: by a certain date. So not on a certain date, but between now and a certain date. So the difference between European and American is that this at becomes by. Okay? And what is an American put option? Well, it's exactly the same as the European style put option, but it gives the owner the right its underlying asset at a certain price, a strike price, by a certain date, between now and expiration date. And again, the time by which you can either buy or sell the stuff is the expiration date, and the price which you have the right to buy or sell for is the strike price. Now let me show you some examples of options. Let's go here. Let's go to New York. This links, here it is, right. So what am I seeing here? No, that's not what I want. These links keep changing all the time. Let's try Euronext. Please, please, do something. Okay, so we have some options here. I'm showing you options whose underlying asset are shares in a bank, a French bank, Crédit Agricole. Now, what do we see about these options? So it tells us, what kind of option is that? It's an American option. Then it tells us some other interesting things, like which currency the prices are quoted and all that. And then you see this. So what is that? So let's see, there is these columns labeled calls, these columns labeled puts. There is a central column labeled strike, and then you have various strikes. And then you have bid and ask, and there have some other numbers which are not terribly interesting. But let me try to explain what these numbers mean. So if you look on the left-hand side of this table, we're seeing prices of American call options. If you look on the right-hand side of this table, you're going to see prices corresponding to American put options. All the options have the same underlying asset, which is shares in this bank. And now you can look at the prices. Now, here's something interesting. There are two prices. So for example, let's have a look at this central green row here. There is a bid-ask. There's a bid price and an ask price. So what are these things? I told you, I lied to you, and I told you in this course we're going to assume that everyone buying and selling things pays the same price. This is almost true. It's not true in this case. If you want to buy one of these call options, so we're talking about a call option on shares in Crédit Agricole with a strike price of $12.60 and expiring sometime this month, then you're going to be paying 25 cents if you're buying them, and you're going to get 23 cents if you're selling them. And similarly, if you're selling put options, American put options with strike price $12.80, then if you buy this stuff, you pay 29 cents. If you sell this stuff, we're going to be paying 26 cents. We're going to ignore this difference between what you pay and what you get. We're going to assume that there is a unique price, which is a good approximation to what you're observing here. But let's ask ourselves, let's see if we can make some sort of sense of the numbers there. Look at what happens to the strike prices as they go up. What happens to the call options, the prices of the call options? The prices go what? What's the relationship, say, between 36 cents and 29 cents, and 29 cents and 7 cents? Do you see any pattern? Prices go down, which makes a lot of sense, because you have a piece of paper that gives you the right to buy something at the strike price. If the strike price goes up, that's a less nice option to have, right? You want to have the option to buy things cheaply. The more you're going to be charged for them, the less attractive such a call option is. And if you look at the prices on the put side of this table, you're going to see that the prices of the puts go up as the strike price goes up, because the strike price gives you the right to sell this stuff. So if you have the right to sell this stuff at a very high price, you're going to be happy. And if you have the right to sell it at a very low price, you're less happy. And when you're happy, you pay more. When you're less happy, you pay less. You pay more for attractive things, you pay less for unattractive. So I'm assuming that people can hear me, but I don't see any evidence of that. Does this make sense? Okay. Okay, so let's go back to our definitions. So here are definitions again. So now let's try to figure out what do these things do for us. Why should we be willing to pay any money to have these things? So let's have a look at European options. And let's start with European call options. And let's start with the European call option on something or another with strike price X. And let's suppose that we just arrived at expiration time. So I'm going to draw a picture of something that lives in 2 dimensions. The horizontal axis is going to be underlying asset price. At expiration. And here we're going to use the vertical axis for the payoff at expiration. Now, let me try to explain what I mean by payoff. Before I do that, maybe let's do it like this. Let me put the strike price on the underlying asset price at expiration axis. All right? So now let's ask ourselves, what would happen at expiration if you observe different underlying asset prices? Okay? So we have a European call option which gives us gives us the right to buy the underlying asset at the strike price of X. What happens if we observe ourselves being in a state of the world in which the market price of this asset is this number, which is bigger than X? Are we happy or are we sad? We are happy. Why are we happy? We can go to whoever issued this piece of paper and say, I have the right to buy this stuff for X. Everyone else is buying and selling this for more than X. I can buy it for X. So I buy it for X, and then I sell it for this much, and I make a nice little profit. This is my payoff, which is the same, this is the same as that. The height of this is the market price at expiration minus the strike price. What happens if I find myself in a world in which the underlying asset price at expiration is less than X? Say this one over here. Am I happy or am I sad? I'm sad. Why am I sad? Because, okay, I have the right to buy this stuff for X, but once I buy it for X, I just bought something for X that everyone else is buying for less than X. I'm not going to be able to sell it. But I don't have to buy this stuff. I have the right to buy this stuff for X. I don't have to. I can take my call option and tear it to pieces and throw it into the basket. I don't have any obligations. I just have the right to buy it. So what am I going to do? I'm not going to buy it. And if I'm not going to buy this asset, nothing is going to happen, and my payoff is going to be 0. So what do we get? What is our payoff function? If the observed underlying asset price at expiration is below X, I get nothing. If it's above X, I get a payoff, a positive payoff. And if I try to capture this whole payoff function, what is it equal to? So the payoff, let me give a name to the underlying asset price at expiration. So expiration would be denoted capital T. So we are going to use S for underlying asset prices. So I'm going to write S of T, meaning the underlying asset price at time T. So the payoff is, I claim, the maximum between 0 and St minus X. If the underlying asset price is above X, I buy for X and sell for S, and I get this profit. If it's below X, I do nothing, and I get no profit. Right? So we seem to be getting a pair function that looks like this. This is really, really important. You need to know this. Do you have any questions about how I got this graph? Okay, so this was the European call option. Now let's have a look at a European put option. So what happens with European put options? Well, something similar. So I agree to sell something at the strike price of X. I agree to do so at expiration. Let's observe. So now I'm going to be more succinct. I'm going to call this the S at expiration time. So that's going to be the underlying asset price at expiration. This is going to be my profit, my payoff axis. And let's put the X here. Now suppose that I observe the underlying asset price being here. Am I happy or am I sad? I can sell for X. Everyone else is buying and selling for more than X. Am I happy or sad?
Sad.
I'm sad, thank you. I'm very sad because, sorry, that's not sad. This is sad. Because I'm not going to exercise my option because I can just sell it for more without my option. So my option is worthless. I spent all this money on it and it does nothing for me. My payoff here is here. And now what happens if I find myself here? So now I can sell this stuff for X. I can buy it for less than X. What am I going to do? I'm going to buy it for less than X and sell for X. And I'm going to make a nice little payoff that looks like this. This is the length of that. Right? So I'm getting a payoff function. It looks like this, and this is the happy part of that's the happy part of the payoff function. And now if I try to write an expression for this payoff function, what is it going to be? So the payoff now is going to be the maximum between 0 and X minus ST. And here's the picture again. Okay. So what are we going to be spending our next few weeks doing? We're going to ask ourselves, here's a piece of paper that gives you this payoff contingent on the underlying asset price you're going to observe in the future, which is something we don't know now. It's a random variable, which we're going to study in some detail. What is the correct price for having these things which potentially give you positive payoffs in the future? So we're going to try to find prices of options, and the climax of this course is going to be when I write down two formulas, one for the prices of European call options and another one for the prices of European put options. All right. So let's look a bit more into this option stuff, and let's try to get comfortable with what they do for us. Let me do it here. So let me give you an example of something that people in finance, greedy people in finance, and people who think they know something about the world may want to do. So let's have a look at the strangle. What's a strangle? A strangle is a kind of portfolio. It's a portfolio which has portfolio, remember, is a bag of assets. So this is going to be a bag of assets, a portfolio, which is going to have two options. The two options are going to have the same underlying asset, and they're going to have the same expiration date. So what can be different about these two options? Let's assume that these are two, I should really say here, two European options. So two European options which are identical, except that one of them is a put option with strike price X1. The other one is a call option with strike price X2, and X2 is greater than X1. So what does such a portfolio do for us? Let's recycle this picture. So when I combine these two things, what's going to happen to me at expiration? So let's put the numbers here somewhere. So here's my x1, here's my x2. x2 is greater than x1. And then what do I see in my portfolio? I see two things. I see a put option with strike price x1. If I just look at that, I say at expiration, I'm going to have a payoff contingent on the underlying asset price, which is given by this green line. And then I also have a call option with strike price x2. So that by itself, in isolation, will give me a payoff at expiration, which is contingent on the underlying asset value at that time, which is described by this orange line. And now, if I have a portfolio of the two, what's going to be the payoff of the portfolio? It's going to be the sum of the payoffs. So here it is. Yeah? So this is what the strangle does for you. Now, why would anyone want to have such a thing? So imagine that the underlying asset is shares in a company. Suppose it's shares in an oil exploration company. Okay? And tomorrow, they're going to have an announcement. They've been looking for oil in Sheffield, and tomorrow they're going to tell the world, is there oil in Sheffield or is there not oil in Sheffield? So what's going to happen tomorrow? If you have shares in this company, what's going to happen to your shares? If they found oil, the shares are going to go up a lot. If there is no oil, this company is going to go bankrupt, possibly, right? So suppose that the price now is around here. Suppose that the expiration is tomorrow. So you know, whatever happens tomorrow, we're not going to be anywhere near the price now. We're either going to observe a price collapse or a price blow up. And I want to benefit from either scenario. I don't know if I should be buying those shares or short selling these shares. I want to make money no matter what, which is what people knowledgeable of these things want to do in life. Okay, so how do you do that? You buy one of these, right? You buy a strangle. Tomorrow the company goes bankrupt, and you say, great, I just made this profit. Or maybe the share price multiplies by 3, and you say, that's even better. I made this profit. Okay? Is this making sense? Do you understand why people might be interested in such a thing? If you keep not talking to me, I'm going to stop talking to you. So talk to me. Okay, now we have about 10 minutes, so let's spend about 5 minutes trying to do this quiz, and then I'll show you how to do it. So what do we see here? We're given one of these pictures. We're given a payoff function of something, of a portfolio. We're told, we're trying to think of a portfolio which consists entirely of European-style put options on a stock, on shares in the company, say. Now, the European puts are going to have different strike prices, but they're going to have the same expiration time, capital T. And you want this portfolio of these European put options, so you're going to put together these put options, and what you want to achieve is, in a sense, the opposite of these triangles. You want to make a profit when the price, the underlying asset price, is around 20. So you want to build a portfolio of options which gives you this pair function at expiration. This pair function is a function of the underlying asset price at expiration, which we don't know, And it's described by this graph over here. So what should we put inside this portfolio? Okay, so now roll up your sleeves, scratch your heads. Tell me what to put in this portfolio. Roll up your sleeves, scratch your heads. Okay, you have 4 minutes. Okay, let's start doing things together. Let's have a look at this graph and let's identify a bit of it which looks a bit like a put option. So I claim if you concentrate on this bit of the graph, this looks like the payoff of a put option with strike price what? This is going to be quicker if you talk to me. If I look at this graph over here, this piece of the graph, this looks like a payoff function of a put option with a strike price of, say it again, 30, right? Let's draw a picture of the payoff function of a put option, the European put option, with strike price of 30. So the payoff is a function of the underlying asset price at expiration. and it looks like this. You get nothing, 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 and then you start getting something like this. Let me do this correctly. Then you get something like this. But if we just look at a put option with strike price 30, the problem is that it doesn't do what we want it to do. It keeps on going like that. But that's okay. Let's fix this. Let's start by putting one put strike is 30. Now, we don't want this, we want that. So what do we have to do? We have to not disturb this bit of the picture so far, but now we want to turn this line of slope -1 to a line of slope +1. We want to turn this blue line into a line that looks like this. How do we do that? How do we turn a line of slope -1 to a line of slope +1? We add a line of slope 2. Yeah? So we want to add something whose payoff is 0 beyond this point, but before this point, the payoff function is linear with a slope of 2. How does linear with a slope of 2 being 0 here looks like? It looks like this. And then 0 there. Okay, let's have a look at that. Is that the payoff function of something? It's not a payoff function of one put option or two put options, but this would be the payoff function of -2 put options. Now, what do I mean by that? This is the payoff function of -2 puts with strike 20. What does it mean, -2 put options? If you have 2 put options, how can I have -2 put options? So, for me to have -2 put options, I have to issue you